And this is our quarter round function. We can just call that our quarter round function. And it takes, it'll probably take the state too. I will in fact type that. It takes probably the state A, B, C, and D. Then we just need to call this quarter round function in a loop. So if we just write a loop, so we might do 10 rounds to start here. And so we would just call our quarter round function. We would pass in the state. We'd have to initialize the state, of course. We pass in our state, A, B, C, and D. And we would just continue that down until we had completed all 8 of these. So once we finish going through this loop, we're going to be left with a state matrix, our state matrix, but mixed, so matrix prime. And at the end, we are going to add that back in with the original state matrix. And keep in mind, when we say addition here, we are talking about modulus addition. So this is a 32-bit number. Adding to a 32-bit number, they will wrap around. So you're not actually keeping either of their original states from state matrix or state matrix prime. So you'd have like, let's say we had 0 constant plus 0 constant prime, or in more like code style terms, it would basically be like your final element is your initial element plus your, we can call it mixed element. So we need to take the state matrix prime and the state matrix and add them together to get our final output 32-bit word for every position in that. And then that becomes our ciphertext. All right, so let's start to work on some of this code. All right, so let's name this X cha 20 provider.c. And well, we're going to need a header. And we'll probably just name it the same thing, but with the header tag. We're going to need string.h for memcopy. We might need something else, I don't know yet. And then we need to grab our constants. Let's see. Okay. The constant is the word expand 32 hyphen byte K. All right, so static constant, we want to use smart data types here. UNAT, and this is our cha-cha 20 sigma, which will have 16 elements. And the hex version of that will be second row would be and then we would have so that'll be our constants array. Before we build our block, we're going to need some load and store functions. So we will need, let's see. Well, Cha-Cha defines a state as two 32-bit little endian words. So we'll need something that turns 4 bytes into a word and something that turns a word into 4 bytes. So let's see, that'll look something like, it's 32-bit, so we'll use a uint32. We can prepend them with XCP so we never have symbol conflict with anything else that might be added onto this file system. So we'll load 32, and this will take a constant uint8t uint8t of, so our 4 bytes. And we just need to return them as int, not unit. So we're just going to cast that.